Hello, welcome to my Physics 2211 lab for review. For this lab, we were asked to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring, then compare the predicted motion and the observed motion of the mass in the x and y direction, and finally plot the energy changes that we computed in the model. So in the video, we have a spring and a mass, making the only forces work on the system, gravity and the spring. As you can see, gravity equals mass times the gravity constant. And then for the spring force, we have K, which is the spring constant times the stretch. After adding the two forces up together, we can apply Newton's second law. Change in momentum equals net force times change in time. And then while doing this continuously in short increments of time, we will get a graph of how the mass has moved oscillating in the system. The next topic we're talking about is energy. So as you can see here, these are the energies of our system, and the changes of all those energies equaling 0. And since energy cannot be created and destroyed in the energy principle, the system, if we did it right, should have a total energy that constantly doesn't change. Let's look at the code. As you can see, we have a few of the variables that we discussed earlier to solve for gravitational force and the spring force. We also have the relaxed length of the spring here. So in order to get the relaxed length of the spring, we actually got it from the pre-lecture video number 52. So what they did was they have the period of oscillation of the mass, and then using that formula, they could rearrange it to solve for the relaxed length of the spring. The part in the middle allows us to use the CSV file that contains all our x and y components during the observed time of the spring mass system. The next part of the code specifies the vector L, which describes both the length and orientation of the spring. And then here we have the different types of energies in our system defined. Finally, this is where we go through and actually graph out our spring mass system. So the spring mass system travels for 9.4 seconds in the video. Here we assigned our initial energies. Then we calculate the gravitational force, spring force, and net force. And like we talked earlier, we applied to Newton's second law. And then we figure out the new spring. Then we update the spring. And then calculate the new energy changes and repeat these steps until the time runs out. As you can see, the experiment proves the energy principle to be right. Our change in energy is 0, as you can see by the orange line. We have this alternate changing pattern happening between kinetic energy and potential energy. And if you look at the graph, another interesting to recognize is that in the y position compared to the model, the experimental data is a little bit slower or skewed to the left. This could be because of drag and other energy forces that we didn't account for. And then if we compare the x and the y components, we can see that they have a slight difference, with the x component being a little bit bigger than the y component. This could also be explained through perhaps unknown energies or forces that we didn't think of or consider.